So now we're going to import actual data, not image data, but actual, recorded experimental data, and do some analysis with it. I will say that a lot of times, right, people will use pandas for this. Right, and so you can go to pandas.pydata.org, right, and that gives you a huge statistical package, right, that people use for pandas. I'm going to show you some ways to do it by NumPy, so that we could just get started with doing this. I'm going to import the perrin data for Brownian motion, which is a random walk problem, or random walk data. I'm going to import NumPy. Excuse me. You notice that I import PyPlot, but I don't use it here. I actually chunkified this program, adding layers on layers on layers. So the PyPlot I don't use in this iteration. I use it in the next one. It's just 2 extra lines that we'll tack on the end. NumPy will load the text. It will load a text file, flat text file, flat data file. Notice that this is .csv, comma, separated variables, right? So my delimiter is a comma. You can have a CSV file that's separated by spaces, by commas, by tabs, colons, semicolons. There's all. You pick a delimiter, right, to be able to separate the thing. As long as you know what it is, as long as you know what the flat file looks like, you can import it. All right, this thing is going to, using NumPy for everything. It's going to give me the size, the shape of the data file. It is going to extract the size of a row, right? Because this is always in row column notation. It's going to extract all of the x values and then extract all of the y values. For those of you who are in linear algebra, they will create a vector for those values. So it'll be a column of data, single data values in every single row, instead of data pairs. Then it'll give me the size, the shape, the max, the min, the mean, and the standard deviation. This is the population standard deviation for all of those x values, and then I'll do the same thing for the y values. It's kind of very straightforward. The biggest thing is loading the data file. Notice I'm using 72% of my memory right now. When I loaded those image files, that memory value usage went way up. This, not so much. I'm going to load that whole data set, and it doesn't move. Simply because this is a flat text file data, and it's only 2 columns. If this was a bigger data set, then I would see this maybe move 1-2%. Notice that the data set is an array of floating point values. 508 rows, 2 columns. It can't display all of it, so it displays the first 2 or 3. Then it gives you your x values, and your n is how many rows this thing is. Your x values, it's 508 values in 508 rows. So it's individual values in an array, row array. And then y values, same deal. It's 508 values in a row array. Remember, when you are dealing with a computer, this is not like linear algebra. The first entry is not 1, 1. The first entry is 0, 0. So your 0th row, 0th column. When you do these, when you do this. The mean. Oh, let me scroll up a little. The mean for the x is about 1465. The min is -16. I'm sorry, the max is 1465. The mean is about 0.123, and then the standard deviation is 5.6. If I come down here to the y values, my max is about 1452. My min is about -1683. My mean is 0.051. And My standard deviation is large, right? It's 5.848. Um, you know, that's all well and good. And a lot of people can interpret those numbers and get something from that. Most of us, though, need a graph, right? And that's where this second program comes from. It's the exact same program except for the last two lines. Now, I set the figure size at 10 by 10. You can make this bigger. I just remember that because it's trying to display in this upper right hand window, that if you make it bigger, you're going to have to scroll to see it all. But if you want to include it in a paper or a report, you're going to want to make the figure bigger, save it, because you can do that right inside Spider. You can save it as an image. It'll save it as a PNG. Or you can save it using Python. There's a way to do that. I'll show you how to do that as well. And then there's it actually is going to plot the thing out with markers. And let me just show you what that looks like. Because I already have the data file loaded, it goes much faster. And if I pull up the plot, notice it's giving me an X and Y axis. 1, 2, 3, 4, 5, 6, 7 tick marks. Nice box around the whole thing. And it is a nicely distributed set of data. This will, if you are looking for a randomization set of data, this will work well for you. If you don't want to use the built-in random number generator and you want to use, the random set of stuff here. In any event, that's the first two, and that will get us started on processing data and flat data files.